Hello, everyone. Today, we will be covering Chapter 6, Bitcoin. This chapter primarily includes the concept of Bitcoin, its development history, and its current state, core concepts of Bitcoin, and the Bitcoin blockchain. Now, let's begin with Section 1, the concept of Bitcoin, its development history, and its current state. Bitcoin is something most of you have likely heard of. It is a form of cryptocurrency that is fast, secure, and borderless. Bitcoin operates as a decentralized peer-to-peer network system and is generated through a process known as mining. This process involves built-in algorithms that regulate mining functionality within the network. Essentially, Bitcoin is an integration of multiple technologies. The Bitcoin protocol is a decentralized peer-to-peer network. The blockchain serves as a public transaction ledger. Distributed mining enables decentralized, mathematically deterministic issuance and transactions of currency. Scripting facilitates a decentralized transaction verification system. In 2008, an individual or group under the pseudonym Satoshi Nakamoto published the white paper, Bitcoin, a peer-to-peer electronic cash system. This paper introduced a system based on cryptographic principles rather than trust, utilizing a proof-of-work mechanism to create an electronic payment system. With Bitcoin, any two agreeing parties can transact directly without intermediaries. In 2009, the first ever Bitcoin block, known as the Genesis block, was officially mined. Let's take a look at the Bitcoin ecosystem. It is essentially composed of four key aspects: generation, storage, circulation, and financial derivatives markets. First, let's explore Bitcoin mining. Bitcoin is closely tied to mining because it is only through the mining process that new Bitcoins can be obtained. Over time, mining hardware has evolved from the initial CPU-based mining to GPU, then FPGA, and finally ASIC. As a result, the cost and price of mining hardware have gradually increased. Now, let's compare different mainstream mining machines. ASIC miners, GPU miners, and CDN miners all support multiple cryptocurrencies. In terms of consensus mechanisms, ASIC and GPU miners primarily operate based on proof of work, while CDN miners mainly utilize proof of data, which relies on shared storage space. As for power consumption, mining machines generally have high energy demands, consuming significant amounts of electricity. However, CDN miners tend to have relatively lower power consumption. So what are their advantages and disadvantages? Of course, each has its own. Cloud miners, on the other hand, effectively integrate the characteristics of the three mining machines we just mentioned. Here is the current state of Bitcoin mining farms. Inside a factory, rows upon rows of racks are densely packed with various GPU or FPGA miners, mining at full capacity. What about the cost of mining a single Bitcoin? We can calculate it as approximately the daily electricity cost plus the daily depreciation of the miner, divided by the user's computing power multiplied by the per block output, then multiplied by 144 and divided by the total network hash rate. Now, Bitcoin cloud mining has also emerged, meaning you can rent a miner in the cloud to conduct mining. This is the global distribution of Bitcoin nodes. From the distribution map, the top three countries are: first place, the United States; second place, Germany; third place, France. What about China? It ranks fourth. So how do you buy Bitcoin? Purchased Bitcoin is typically stored in an exchange account, somewhat similar to a traditional bank card. However, to truly own these Bitcoins, you need to withdraw them and transfer them to your own wallet, which is essentially just an address. Now, regarding exchanges, Transactions are matched through order books and are recorded internally by the exchange, making it a centralized ledger. Blockchain transactions only occur when users initiate deposits or withdrawals, and only then can they be found on a blockchain explorer. This brings us to Bitcoin wallets. A Bitcoin wallet actually stores Bitcoin addresses, similar to a bank account number, along with private keys, which you can think of as a bank card password. Its core function is to protect your private key. If you lose your wallet, unfortunately, you will permanently lose access to your Bitcoin. Thus, Bitcoin wallets have several functions: generating sufficiently strong private keys, deriving public keys and addresses from private keys, synchronizing blockchain headers, checking blockchain account balances, providing addresses for receiving Bitcoin, signing Bitcoin transactions, managing used addresses, and generating new ones, as well as additional functions like backup, recovery, and key management. Based on decentralization levels, Bitcoin Wallet can be categorized into full node client, which maintains the entire blockchain data and are fully decentralized; lightweight client, which only maintains blockchain data relevant to the user and are mostly decentralized; centralized wallet, which relies solely on their own centralized servers and do not synchronize blockchain data. The full node wallet, Bitcoin Core, is essentially the official Bitcoin wallet client. In addition to storing private keys, it also keeps a record of all blockchain data, allowing local verification of transaction validity. Of course, its advantage is that it's the most complete and secure wallet. However, its downside is that it consumes a significant amount of hard drive space. By 2018, its blockchain data size had reached 223 gigabytes. Now, in 2025, this data is estimated to have doubled, reaching nearly 500 gigabytes. In other words, a 500 gigabytes hard drive would be required to fully download this wallet. Here is a screenshot of the Bitcoin wallet interface. The interface appears clean and simple, but behind it, a 500 gigabytes database is running. Only after the data synchronization is complete can the wallet function properly. Before that, no transactions can be processed, nor can the account balance be updated. Alright, everyone. That concludes today's lesson on Section 1.